How are you, everyone? It's so nice to see you again. Tony, what happened to you? You were absent for a long time. How are you today? Okay. Don't get sick next Tuesday. Okay, we are here for a review today. Does anybody have any question, comments, concern, anything before we start? Nothing? So, I didn't make the exam yet, but I think from composition, I'm going to ask two questions. One is about f of g of x, where you put one function inside another function, and another one is evaluating that. So two different questions, you're going to work with four different functions. For example, here, question one, we have f of x is square root of x, and g of x is 2x plus 1. So if they are asking you to find f of g of x, it means you are inserting the g function inside the f function. So whatever is inside, you put that into the outer function. So f of g of x is same as f of 2x plus 1, because this is what our g of x is. So we go to the f function and write its structure. Structure means its square root, and instead of x, we write 2x plus 1. And we have nothing to do. So this is our final answer. On the other hand, if they're asking you to find g of f of x, it means you're putting the f function inside the g function. So this is same as you are trying to find out g of square root of x, because this is what the f function is. So you go to the g function and we write the structure of the g function, but we don't write any x. So the structure of the g function is 2x plus 1. But instead of x, we are going to substitute that with the entire g function, which is square root of x. So in other words, we have 2 square root of x plus 1. And we have nothing to do, so 11. So whatever function is inside, it goes inside the outer function. And then if you can simplify, you work more. If you can't, you just leave it alone. Do you remember this doing in our class? Great. So I will ask one of these. Then I'll ask something like question 3, where we have f of x is x squared minus 2x plus 3, and g of x is x plus 3, and they want us to find what is f of g of 1. So this type of question is actually easier to work with. What you're going to do is you're going to first find how much we have for the inner function. So we go to the g function and we substitute all the x with 1. Our g function is x plus 3. It means it's 1 plus 3. In other words, it's 4. So first we find what is f of g of 1. Sorry, what is g of 1? It's 4. So that means the thing we have here is same as we are trying to find out what is f of 4. So what do you do now? Good. We go to the f function and we say, hey f, right now if x is 4, so you're going to substitute all the x we see in that function with 4. So we have x squared minus 2 times x plus 3, all the x turn into 4. So we get 16 minus 8 plus 3. 16 minus 8 is 8. So we get 8, 9, 10, 11. And I'm going to ask one of these in the exam. One from the left page, one from the right page. Funny.
So you only like solve it if groups are going to put for x.
If you have a number for x, you don't have to put one function inside another. You can simply work with the number and then put the number inside the function. Any question? Melanie. Good question. 16 minus 8 is 8, right? 8 plus 3 is 11. Oh, not 16 minus 11, because 8 is a negative. So you have negative 8, positive 3. That will give you negative 5. 16 minus 5 is 11. So, yep. The next, I'm going to give you a couple of these. A few. 2, 3. Because these are easy. You don't have to do any math. Just simply look at the composition and figure out what is the outer function and what is the inner function. It's always easy to find out the inner function. Once you know inner function, you can find out the outer function. What is inner function here in the first one? Dua. Wonderful. Whatever is inside, that's the inner function. That's why it's very easy to see the inner function. So start with the inner function, and then if you take it out, whatever remains, that's the outer function. So what is our outer function? Square root. And then since we pulled out our inner, so we replace that with an x. And that's it. Start with the inner function. For the outer function, replace all the inner function with just one x. Easy, right? Gerald.
Why is 2x?
Because it says G is inside F. Look at the composition. G is inside F. So whatever is inside, we first find out that function, and then we go to the outer function. If I give something like number 6 in the exam, I'm not going to tell you what's the G function. So you have to figure out what's the G function and what's the outer function. But they're nice. So they are telling you that the G function is 5x. So what's the F function here?
So you're not going to give me something like number 6?
No, if I give something like 6, I'm not going to give you what is G of x. You have to find out what is G of x.
You find out G of x and F of
So you see here, they gave us G of x, so it's easy for us to see. But in the exam, what you could do is, whenever you see two perfect square, write them into one thing with a square outside. That will make your life easier to see what's inside and what's outside. 25x squared is same as 5x whole thing square minus 3. So now you can see G function is 5x. So what is F function? X squared minus 3. So G is all, I mean, not always. Here our G is inside. So whatever we have inside, that's the G. You replace G with X, it becomes F function. In the next one, our F is inside. So which function is inside? X minus 4. See, this is inside. And then a G function is the outer one. Perfect. If you replace the G function, if inner function with X, whatever you get, that's the outer function. I love this, so I'm going to give you a few, 2 or 3. If I have enough space, maybe I can give you 4. Any question? No. The next ones are fun questions. I'm going to give you a few, like 3 or 4. They're asking which of these are from, which of these represent one-to-one function. Do you remember how do you find one-to-one function? Horizontal line test. So if you draw a horizontal line, if you get the intersection more than once, is it a one-to-one function or not? No, not one-to-one function. We care about one-to-one because only one-to-one function has inverse. Other functions that don't have inverse. So what is B? Yes or no? No. We have 2 intersections. How about C? It is. We have only 1 intersection. And you know, one thing I noticed in your homework, that even if you get the question correct, but if you click on similar question, they give you a different graph. So if you want to have more practice, keep clicking on similar question, similar question. Every time you click the similar question, you get a different graph. So practice with the graph if you want to have fun. So these are easy. So I'll give you 3 to 4. Let's see. 1 from finding the inverse. Find the inverse function. So which one you want me to do?
Said that whatever X or Y is not one-to-one.
First one?
Yeah.
So f of x is 1/4 of x minus 2. We find inverse function using only 3 steps. What is our first step? But do you have any y here? So step 1, if you don't see y, make it to y. We don't see y, so this is y. Y is 1/4 of x minus 2. Now the second step, we switch them. X becomes y, y becomes x. We switch their partners. So x equals 1/4 of y minus 2. And now last thing our goal is get this y alone. So which one we get rid of first, the 1/4 or -2? So what do? Add 2. So we get x plus 2 is 1/4 of y. We don't want the 4 on the denominator, so I multiply by 4 both sides. They cancel out. Our y is 4x plus 8. So these are easy, only 3 steps. Let me also show you the next one. F of x is 6x plus 1/5. Y equals 6x plus 1/5. Before that, we need to switch them. X equals 6y plus 1/5. We don't want the denominator, so I multiply both sides by 5. Five x is 6y plus 1. Our goal is to get this y alone. One is already added. Subtract 1 from both sides. We get 5x minus 1 is 6y. Divide by 6. They cancel out. So y equals 5x minus 1/6.
Question. So let's say that like 4 different questions of
Mhm.
the 5 times the 5.
No, I can keep it. Any question on inverse? I might give something like this. You have a picture and you're going to figure out which multiple choice makes sense for the picture. If I have space in the exam, I'm going to give this type of question. So in here, the first question they are asking is that it's a polynomial with degree 3. Degree 3 means what? What type of polynomial? Cubic. So something like y equals x cubed. Do you remember the shape of cubic function? So is it a cubic function? No. Let's go see. It's a one-to-one function. Definitely not, because there's so many intersections. Let's go to D. D says it's a polynomial with degree 1. What type of polynomial has degree 1? Linear. Something like y equals x. So it's a line, either this way or this way. Is it a line? No. Then none of the above. We ignore that for now. We go to the option B. It has no inverse. How do you know when something doesn't have inverse? If it's not one-to-one, it doesn't have inverse. So it's not one-to-one, so it doesn't have inverse. So option E also doesn't make sense. Any question?
than one at least, not space.
Wait, so, you said that has, if that has no, inverse.
Mm-hmm. To have inverse a function must be 1-to-1. That's the rule. That's why we care about being 1-to-1 or not. Because if they are 1-to-1, they have inverse. That are not 1-to-1, they don't have inverse. And 1-to-1 means for every one x, we have only one y value. For every one y value, we have only one x value. That's why it's 1-to-1. From one number, we are going to that one number only. Okay. Transformation of exponential. One from here. I prefer something like B because it has everything. Y equals -2 to the x plus 1 minus 3. And you must indicate and write down your asymptote. So remember, exponential has what type of asymptote? Horizontal or vertical? Look at the shape of the exponential. Vertically, it's going up forever or going down forever. But horizontally, it doesn't. So it has a horizontal asymptote because it has a limit to go on the lower side. So it's y equals whatever we get from the up-down shifting. That's the horizontal asymptote. Horizontal asymptote. So if you have a negative sign in the front of the function, what do we have? Reflection about the x-axis. So the original one goes upward, its reflection will go downward. This is what reflection means. Y equals negative b to the x. And this is y equals positive b to the x. So now negative on the front means reflection about x-axis. You have a number next to the x. Which direction? Left or right? So plus means left. We are going left 1 unit. And 3 is single, alone. Which direction? Down. So anytime a number is single, alone, it's up, down. If you forget, remember, when you are alone, sometimes we feel up, sometimes we feel down, right? Especially, mainly we feel down when you feel lonely, right? So when you're lonely, means you're alone somewhere and you're feeling down. So single number alone means going up and down. Okay. So the original one is this 2 to the x. It goes to the y value 1. You must do the original one because this is 1 point. And then we are reflecting that. So the reflection goes through -1. And now we are shifting that reflection 1 left, 3 down. So this point goes 1 left here, 1, 2, 3 down here. And oh, I forgot. What is our horizontal asymptote here? Y equals -3. So let's draw the -3. This is -1, -2, -3, -4. So this is the line that we cannot cross after the transformation. Y equals -3. So you draw your wall, which wall you cannot cross. So we know our graph has to be below that, and it's going downward, something like this. I don't have enough space. So all I want to see here is the original graph, and then the reflection, you have to draw it, but make sure you show me what a positive one turns into negative one, and then you're going one down, one left, three down. Don't forget to draw your asymptote. For asymptote, 2 points. If you just write -3, you're losing 1 point. The asymptote is not a point, it's a line to equation. So y equals 1 point, and then the number gives you another point. So 2 points here, 1 point here, then the reflection left down gives you another 3 points. It will be around 6 points question. Okay. Any question? And now solving exponential. We have 4 types of exponential. I might give 1 or 2. Definitely 1. If I have space, then I'll give you 2. Huh? You want 4 of these? These are easy. If I have space, I'll give you more, but definitely 1. So student want this more. I'll take this in consideration. Okay, the first type is easy type. We have the same base. What do we do? Cancel. So we have 2x equals 3x plus 2, and we solve for x. Since our, it's okay, you can do anything. You can subtract 3x. So you get negative x is 2, but you're not looking for negative x. You're looking for positive x.
It's like swap it, so it's x.
X equals -2. And we are done. We don't have to check anything. We need to check for log function, log equation. Now the second type, 2 bases are different, but we can convert the bigger base into smaller base. So we keep our smaller base, it doesn't have any power, so we put invisible 1. When you don't have any power, you always have 1 there. Not 0, it's 1. How can we rewrite 16 using 2? 2 to the 4. And this has an extra power. Now we have the same base. What do we do? Cancel. So we have 1 in one side, and we multiply them. 2 powers together, we always multiply them. So we get 12x minus 4. And now basic algebra. We add 4 to both sides. We get 5 equals 12x. Then divide by 12. So our x is 5 over 12. So second type. All of these are finalization question, okay? In the finalization, they give 1 of them. But which one? It depends on their mood. But at least 1 from the 3. The first one is too easy. They don't give the first one often. But the other 3, it's always 1 of them. Now the third type, we have same thing. We can rewrite the bigger base using smaller base. So smaller base has 2x minus 3. We are going to rewrite bigger base using 3. 3 to the 3. We have now same base. Cancel. So 2x minus 3 equals 3x minus 6 because we multiply them. Add 3. We can add 3. So these cancel out. 2x is 3x minus 3. We can subtract 3x. Negative x is negative 3. You can do it in your mind. X is 3. These are easy, not bad.
Yeah, extra credit.
Yeah, oh, yeah.
Extra credit.
So I don't.
You can do that also. You can subtract 2x instead of adding 3. Our math is amazing. Like, it doesn't matter which approach you take, at the end, you reach your goal. That's why I love math, because it has a goal, unlike literature. Why Romeo wanted to die for Juliet, or why Juliet did whatever they did for the Romeo. Like, come on, it is so many answers. How do they know that our answers are wrong? You know, like, did they leave Romeo and Juliet with them? Like, did they live with them? Like, how do they know Shakespeare's thoughts? Who are they to judge our judgment, right? I really don't understand literature teachers. Like, come on. I always hated that because I never got A in any of my literature classes. I hate that. So yeah. The next one, fourth type, hard type. We have completely different bases. We cannot rewrite the smaller one using the bigger one. We cannot use the bigger one to rewrite the smaller. We cannot use the smaller one to rewrite the bigger one. So what do you do in this case? So how can you rewrite 8 to cube? And we have 4x minus 1. Oops. 4x minus 1. How can we rewrite 4 to square? And now we have the same base. We cancel. And we have 2 here and 2 there. So for your convenience, let me write this out before I multiply. Please.
So I just wanted to see that why doesn't 4y is like a common denominator?
In order to use them as a base, we have to have the number with a power. Can you write 8 as 4 with some number, 4 with some power? Like 4 square. What is 4 square?
Oh, so it's gonna work as a power.
Only using a power. No multiplication allowed. We can write 8 as 4 times 2, but timing is not allowed. Only power. So what do we have? 12x equals minus 8, yeah. And now we can subtract the smaller one. And if you don't have time, you want to do 2 steps in 1 step, you can also add 3 to both sides. (4x equals negative 5). So 1 definitely more if I have space. The thing is, I want to keep my exam as small as possible so that I can grade easily. So I don't want to have more than 6 pages. I know it's better, but it's hard for me to grade. So for me to grade easily, I want to keep my exam smaller, shorter.
I was gonna say because game time one was like how to
True. Like final exam. Final exam, I check the work. If everything is correct, final answer is correct, that's it, I give points. And if something is wrong, no points. So grading final exam is easy because they don't have partial credit. But grading in-class exam is hard because I have to think how much partial credit I should put there, how much you deserve. Okay, the next question, we have either log or exponential. So what is the shape here? Is it a shape for the log or shape for the exponential? Exponential. So log cancel out. Now think about the original one. Since it's an exponential, the original one has this shape. It goes to the y value 1. Always. Without any transformation, the original exponential goes to the y value 1, always. Now, if you compare the original one with the transformed one, what do you notice?
The first one you mean?
I'm talking about the graph.
Yeah.
This is the original one and this is the transformation.
Right.
So how did you transform?
Move down one.
So which one makes sense? The top or the bottom? B. Remember, single alone means down or up. So here our negative one is alone. So this is the correct answer. On the other hand, this negative one is next to the x. So x is its friend. It's not alone. So it's going right or left. In this case, it's going right. So if we have a number next to the x, it's left, right. But if you have a number that is single, alone, lonely, it's up, down. Again, if I have space, I'm going to give this type of question.
So we're not gonna see it unless you have space. Okay.
So my priority is back and forth 3 pages, so total 6 pages. So I'm going to give all the important questions in the 6 pages. And then if I think, well, I have so many extra things I can put, maybe I can have 1 more page.
What kind of word problem?
2.
You go over that already? You already went over them?
No.
No.
After this comes word problem. So in here, I'm going to ask 1 from here, 1 from there. Because in the final exam, they should have 2 of these, I think. So 1 in the non-calculator portion and 2 in the calculator portion.
Is this the one where we use log to bring the
Power down. Okay. So these will be in the calculator portion. When do you like a calculator portion?
Why?
Because in the exam, student gets frustrated. Like the rule is 3/4 gets non-calculator time and 1/4 get calculator time. So what I try to do is I give in 1 hour 40 minutes, I give 1 hour, let's say 20 minutes in non-calculator, and then another 20 minutes in the calculator. But students are so confused, like, oh, I'm not done. Oh, I'm this. Please give me more time. Please give me that. Like, I hate that when you have 2 parts. They drive me crazy.
Not get more time than us for the same exam. I'm not fair.
But in the final exam, you all will be same.
Yeah, but that's not fair.
I know, but they're special. There's 6 students.
Just 6 students?
SICK doesn't mean SICK. It's SEEK. It's a program.
Six.
Oh, not 6. SICK. It's a program. It's a special program for special students, so they get special treatment. And that's why they don't take advantage of that. They simply don't care. Okay? They don't care. Like they have so many opportunities and everything. They have extra, they have their own tutors and everything, but they don't care. They don't go to the tutor or they don't study hard enough. Like they have so many advantages, but they don't take the advantage of those advantages. Mm-hmm. People who are not in the SIG program, they want to get into the SIG program, but they can't for some reason, I don't know. But people who are in the already SIG program, they don't care.
Because you get accepted into the school through the program.
Mm-hmm. It's like the only reason I love teaching SIG is because it has more hours, so I get paid more. But I hate teaching the section. Yeah. I asked myself, like, why, like, if I hate teaching that, like, why I keep accepting the request of teaching the SIG section? And then I realized, oh, that's because I have more money in there. So I'm like, okay, no problem. I'll just try my best to teach them as easily as possible.
You only teach 10:30, you don't teach 10:30.
In every fall, I teach 10:30. Every spring, I teach 10:23. Sometimes they give me also 2009. Sometimes they give me 2003. 2003 and 9 not guarantee, but 10:30 and 10:23 is guaranteed because we have so many sections for those. Yeah. Okay, these two. So the first one is we have one exponential on one side and number to the other side. They both the same. Let me just take B. 3, 2x minus 2 is 2. So in this type, we have an exponential and a non-exponential. The two bases are completely different from one another. Since our variable is on the power, so we need to bring it down. What do? We apply log. Especially natural log is better because the next one we must use natural log. So remember, log hates power. So anytime it sees power, it just brings it down as a coefficient. So we get 2x minus 2 inside the parentheses. ln of 3 equals ln of 2.
This is like the same thing we saw before, changing the bases, but this is where the bases are completely different.
So you have 5 different bases, 5 different cases. And then in this case, completely different bases, it cannot do anything. So we go to the log and say, hey, log, help us, please. So, at home, I have 2 nieces and nephews. No, 2 nephews, 1 niece. And they are naughty, like, they like to jump and then not listen to their parents and everything. So their parents tell them, hey, if you don't listen, I'll tell your aunt. And then they're like, oh, please don't tell. So like they use me as a like shield to listen to them. So that is same thing like log. We don't know how to bring down the power. So you go to the log, like log, help me please to discipline them. So log brings it down and then you can get it alone. Okay. So what do we do to get our x alone? Good. We have so many things next to x. So first thing we do is we get rid of the ln. Let me do the rest here. 2x minus 2 is ln of 2, ln of 3. Add 2, add 2. So 2x is ln of 2 over ln of 3 plus 2. We divide the whole thing by 2. And then we go to the calculator. If your calculator doesn't have a fraction option, you need to put parentheses on the top and then divide the denominator. That's what I said. Make sure you play with your calculator, not with your phone.
You're not allowed to know.
In the exam, you cannot use your phone. So if you forget to bring a calculator, you are doomed. So make sure you bring your calculator in the exam.
Can I just do ln of 2 divided by ln of 3 plus 2 and then divide that by 2? But 1.315.
1.315. It didn't mention which decimal place, but I have the answer in 2 places. So 1.32. In the final exam, they'll tell you how many places you need to just round off. Question? Now 1 from 17. Anyone is fine. Let's do D. It looks harder. 3 e to the x plus 4 equals 5.6. So this is the last step of exponential when we have so many extra things with exponential. And this exponential has a specific base e. So we cannot do anything until the exponential is alone. So we subtract 4 from both sides. We want to get this alone. So remember, we can apply log only when our exponential is alone. If it's not alone, we cannot apply the log. So we subtract that, we end up getting 3 e to the x equals 1.6.
Yeah.
We still want the exponential to be alone. So we divide by 3. We have e to the x is 1.6 divided by 3. We are not actually multiplying, we are applying ln. ln is a function. So you're applying the function to both sides. What happened to the e and ln? They fight, they will die. They rest in peace. So we have ln of 1.6 over 3. And then you go to the calculator. We put 1 ln, and then inside the parentheses, 1.6 divided by 3. Some calculators needs the number first and then ln. So make sure you know what your calculator wants. Tell me, what do we have? 6 to 8, so negative 0.63.
Yeah, accept that.
Mm-hmm. For exponential, we don't care. For log, we cannot have any negative or 0.
And the negative is 4?
0. So that's all about exponential algebra. And now, where do we use them in real life? So in real life, we have many scenarios based on your equation. So I'm not going to go over all the questions. I'm just going to go over the formula. We have 2 formulas. One is final equals initial, 1 plus r over n to the power nt. We use this when you compound not continuously. anytime you have a compound annually or daily or monthly or weekly, if you compound something but not annually, this is the formula we use. But if you compound continuously, so only for continuous compound, we use this compound continuously. So when you continuously do something, it's a smaller formula. If you forget, think about this. If you do something continuously, does it become easier or harder for you? If you do something continuously, easier. So see, when you smaller function to work with, smaller equation to work with, all of becomes easier. So continuous means easier function, not continuous means harder function. Okay? Will you be able to remember this now in the exam, which formula to use? Great. So I'm going to ask two from here. One from the money. So one from here. These are money problem, and one from the population. So here, in the final exam, they do the same thing. They ask one from the money problem and one from the population problem. In the money problem, based on our variable, we have four types. Sometimes the final amount is missing. So you substitute everything else and then you solve the final amount. Sometimes the initial is missing. When the initial is missing, you solve for the initial and then you substitute everything else. Sometimes interest rate is missing or time is missing. Anytime something is missing from the power, we need the help of LM. Otherwise, it's just simple algebra. Okay. So do you want me to go over a specific question here?
I wouldn't see exponential growth of the wait, not growth. It was something where the equation it looked like mixed with the
Yeah, but I'm not going to give two.
right?
I'm going to give one from here and
That's the only two that we should remember. Okay.
so in the population, usually they give us the formula. And since they give us the formula, so usually they are going to not tell what the formula. Usually, not always.
Can you go to 21 because it says to find the interest rate.
Interest rate, no problem. 21. It says the an initial investment is 2250. So P is 2250. Is made that is compounded continuously. Compound continuously. Continuously means which formula? Part. P equals A equals P e to the RT. And then it says after 6 years, so our time is 6, the amount becomes 3100. That's the final amount. A. What is the interest rate? They did not give us the interest rate. So they gave us the final amount, the initial amount, the time. So R is missing. Since R is missing, that means you need to, in order to solve for R, we need the help of log. So we substitute everything. Our final amount is 3100. Initial amount is 2250. E to the R, we have no idea, but our time is 6 years. Our goal is to, what is this? Our goal is to get this R alone. So we don't want this 2250. 2250, they cancel out, and we can cancel 1 zeros from top and bottom. So 310, 225 is e to the 6r. Now we scale our e using ln. They will die. We have 6r is ln of 310 over 225. So we put this inside the calculator. Try it in the calculator. I give you the answer not to make your life easier, but to check whether you punch the right button in the calculator. 225. And the whole thing you divide by 6. 0.0541. So it says round to the nearest 100th. 0.05. So this is 10, this is 100. But if you don't see this in the multiple choice in the final exam, you should round to 4 places so that it becomes 5.34%. So if you don't see 5% in the multiple choice, but you see this, that means this is your answer.
So we're multiplying the answer by
100 because it's interest rate. Usually they don't put R equals, they put percentage. So if you don't see 5%, it's 5 and then 2 places after the decimal. So yeah, one of these. It doesn't matter what is missing, you just substitute everything else and solve for missing. If the missing part is on the top, then you need the help of ln, otherwise it's simple algebra. And they will always give you n if it's not compound continuously. So n will never be, they never ask you for n, okay? If it's not continuous compound, they definitely will give you n.
only one.
One from the money and one from the population.
So one from one compound and one.
No. So money has 2 problems, compounds not continuous and compound continuous. So one from here and one is the population. For population, they give you the formula.
So it's either going to be the continuous or not continuous. We don't know.
One. And one from the population. Chris.
When we're looking at an interest rate, we have to make it the whole number, 5.34.
In the final exam, they don't give a decimal, they give percentage.
Okay, but
so you need to convert into percentage.
You know how it says 5% and 5.34%? Are we going to be going with like 5.34? Like, does it have to be
No. So see here, it says round to 10 places.
Yeah.
Sorry, 100 places. So if you round to 100 places after the decimal, this is what you get. Right?
Oh, okay.
But this becomes 5%.
Yeah.
So if you don't see 5% in the multiple choice, that means you have to round 2 more places after the decimal, after you convert into percentage. So everything depends on the multiple choice. If you see this, you're done. But most likely you're not going to see this because rate is always in percentage.
Can you look at the population one?
So in the population one, mostly they give you everything. Let's do the first one. It's non-calculator. So they give us the population. They want us to find if the population size at any time is given by this formula, then when the population will be 160. So let me take a age. For any time during any time the population is 10 times 2 to the t. For any time t. And they're asking when our population will be 160 t. So this is the final amount. Whatever we have on the left side or one side is always final amount. Final. Our final amount is 160. And we are looking for when. When means time. So since we want to get our t alone, what do? We need to get the exponential alone. So zeros cancel out. We get 16 is 2 to the t. Since you're not allowed to use calculator, so you have to think of exponential.
Make the base the same.
Exactly. So it becomes the second type of exponential. We have two different bases, but we can rewrite the bigger one using the smaller one. So 16 is what? 2 to the 4. And we have 2 to the t. Now we have same base.
Oh, that's easy.
Mm-hmm.
How many of those are you doing?
1.
One? Like 3 or 4. Extra credit. You give it an extra credit. Think about it.
Yeah.
Have like a 7 page like yeah, but that's one. But like if we get it wrong, our grade is drop. What if you give us the problems and then you don't grade them until the I want to do that. It sounds like a lot of work. I want that. Think about it.
Okay, then comes log. So for log, I'm going to ask just like exponential. One transformation, one equation, solve the equation, and a few simplifying log. So simplifying log we're going to do later. Let's study the transformation. And since it has a minus, let's see this one. We have a negative in the front of the log. What type of transformation? Reflection.
Yeah, so this is
It's 24b.
so this is for us to graph. Okay.
It's transformation.
Okay.
Now we have a number next to the x. Which direction?
Right.
Right 5. A number is single. Up. Now exponential has horizontal asymptote. So log has which asymptote? Vertical asymptote. Where from we get a vertical asymptote? So we go to the x because every vertical line has a formula x equals something. Because our x is not alone, it's the number is next to that. So we want to get it alone, so we set it equals 0 and y is same. So we're going what right? So let me draw it on the left. 1, 2, 3, 4, 5, 6. The normal log has this shape. Log x. It goes to the x value 1. Now for the transformation, we cannot cross the line x equals 5. So this is 1, 2, 3, 4, 5. So this is the line that we cannot cross. So this is our wall for the transformation. We are taking our x-intercept, we are reflecting it. Reflecting means it becomes opposite. The up portion goes in the bottom, and the bottom portion goes to the top. So this up comes down here. This bottom comes up there. This is what it means to have a reflection about x-axis. You are just reflecting completely. Now that reflection, we are shifting 5 right to up. So 1, 2, 3, 4, 5. 5 is here. We are going 1 up, 2 up. And it's not working. Yeah. For some reason, my ink doesn't want to draw the graph. Let me try it here. What's wrong with this? Something is wrong. I think it's tired. It says, please, no more. My brain is hurting. No, my nib is hurting. So we draw the graph even though I can't do it, but this is the graph we have. Okay. It doesn't stay, my bad. Can I do it here? No. Unfortunately, my ink is not working. No, let's see if it works in the next one. I had to restart. Go ahead.
So the new graph would go to 6 and it's never gonna touch 5.
Because 5 is the wall.
We should not confuse the vertical axis to be x equals 6.
Vertical asymptote is x equals 5, not 6.
We always take the x inside the parentheses instead of the 0.
For vertical asymptote. Welcome back. Can I draw now? Yeah, it's working now. So 1 up, 2 up here, and this is a new transformation. Observe that I have this portion above the x-axis because see this one is closer to the x-axis. So it should be closer to this line here. Like some people draw this way, which is wrong because if this is your x-intercept, this point should be closer here.
Should we draw the point like 2, 6 so that you know that we know that it's not touching?
Exactly. So make sure you show me your work, or at least write down the point. For example, here, like Stephanie mentioned, this point is x6, y is 2. So if you write the point, I'll understand, well, you're correct. You walked the correct distance. Same goes here, but I'm just going to ask one of them, not 2. And if I have space, I'm going to give one of these, multiple choice. Multiple choice is given, and you need to figure out which one makes sense. So you start by observing the shape. What is the shape of this graph? Is it an exponential or is it in log? Exponential has a shape this way. So it's not an exponential. So exponential cancel out. Unless you have a reflection twice. Reflection twice, exponential becomes log.
Okay, minus 2, it starts at 1.
So 1, 2, 3, good observation. The original one always goes to the x value 1. But look at the transformed one. It's going to the x value 3. So you're moving 1, 2 to the right. First of all, this is a square, right? So you also cancel the square one. It's not a square graph. So you have two choices, either B or E. E means you're going 3 units to the right from the original one. But the original one, it goes through 1, always 1. So if you go 3 units, it's 1, 2, 3. You should go through the 4. But you're not going through 4, you're going to 2. So it's 2 places to the right. Now simplifying, usually they don't put them in the final exam. Huh? These, oh yeah, canceling out. So these are just for fun. If I have space, I'm going to give these. In the final exam, they don't ask this type of question. You do. Because when you solve the logarithmic equation, you need the rules.
So we know that log has an invincible base 10.
10. That means our goal is to rewrite 100 in terms of 10. 10 with some power.
10 squared.
So we have log 10, 10 squared.
That becomes 1.
Triangle, they cancel out. The answer is 2. So anytime our goal is to rewrite the argument using the base with some power. That is our goal. The next one is log 3, and we have 1 over 81. If you can see it directly, you can see that this is actually 3 to the negative 4 power.
I have a question.
Go ahead.
So, when you draw the triangle, does that become 1?
Triangle means they cancel out.
Right, so that would be 1 times negative 4, 1 to the negative 4 power.
1 times negative 4.
1 times negative 4.
That's why I said this is for fun, because this is just cancellation. You cancel them. The next one, log base 3 squared. They cancel out everything. What remains? 2.
I feel like you should give like A and what does that say? E? No.
All of these are easy. Look at F. Let me do F here. So F says 3 to the power log base 3, which has argument 4x. Anytime you see the base and the same number next, they all cancel out.
So that's because they should be
All of these are rules.
power.
Mhm.
And it's the same thing.
So this base and log base are the same thing.
It's the same thing.
So they cancel out, they become 1. When you cancel things out, they become 1, okay? Not 0, it's 1. The next one, log 1/1000. So we know 1/1000 is 10 to the negative 3. So it simply becomes log base 10 and then 10 to the negative 3. Duas triangle. What remains? Negative 3.
How many of these are going to be on the?
It depends on the space.
Oh, this
Yeah. I don't want to make my exam more than 3 pages. I'll see.
What if it's you on the last question?
Quiz. In a quiz, you're going to see this question. If you take it on my math lab. So we have ln of 5th root of e. 1/5. Anytime we have something between e and ln, they cannot fight because we stop them from fighting. So we get rid of that. We rewrite, and now they're resting in peace. We left it 150. Okay? We're not doing any math here, right? We're just rewriting things and canceling out. No, Q means quiz. In my MATLAB quiz, I took this question from my MATLAB quiz. So yeah, if I have space, I'll give you a few. But definitely one from the expansion. Something like this one. We have log base 3, 5x to the 6, 3 square root of y to the 7, z to the 5. But before that, anytime you have a radical, you need to rewrite your radical.
Where? Get the log 3.
Huh?
Yeah, log 3.
Oh, it doesn't have anything, my bad.
So log 5. Wait, so we have.
Before that, let's work with this portion. We're going to separate them and rewrite them. So when you separate them, it becomes square root of y to the 7, square root of z to the 5. Once you separate, we need to rewrite using exponent. So this becomes y to the over 2 and z to the 5/2. So that means this expression is log 5x to the 6, 3 y to the 7/2, and z to the 5/2. And now we see all the powers, no exponent. So we distribute our log. It's not actually distributing, but you can think of it as distribution. How many logs we are going to have? 5. So log, 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 log. 5 log. The first one is?
5.
And the sign goes between them. The next one is?
Plus 6.
X to the 6 minus log 3. I rewrote. The next log is y to the 7/2. And the sign is next. Another minus. And we have z to the 5/2. If you leave it alone, you're going to lose points because this is not done. So what do you do? so many powers we have to deal with. We bring all of them down. So log 5 plus 6 log x minus log 3 minus 7 half log y minus 5 half log z. These are finalizing function, okay? In the exam, definitely in the final exam, definitely you'll have one of these.
And we're gonna see one of these on the next exam.
One.
Sorry, is that gonna be-
Now the other way around. The expansion is given combined into single log. Something like this one. But I'm gonna give more terms.
So that one is a log with a fraction.
So 3 log x minus log y plus 2 log z. Before we combine, what do?
You set the powers.
We take the coefficients, move them on the power. So every coefficient must go to the power. So log x cubed, the next one doesn't have any power, we'll leave it alone. The last one has z squared. So going backward, what we did on the left page. Now we have no more coefficients, so we convert them into a single log. Since we have plus and minus combination, so we are going to have a fraction.
Have x cubed on the top,
X cubed on the top,
y at the bottom.
y on the bottom,
Square root.
z squared on the top.
I'm gonna try to confuse you by putting the signs in the.
Yes, I'm going to give 1 plus, 1 minus, 1 plus, 1 minus. Huh?
Why?
It's fun. For example, it doesn't have anything, but let me make up one of them. For example, something like, let's say log x squared minus log z cubed plus log y5 minus log, let's say 7. See the combination, plus minus plus minus.
Okay.
So what would be the answer?
Means x squared y to the
X
fifth
squared on the top, y to the 5 on the top, because they both are positive. Z cube bottom, 7 on the bottom, because these are minus. But make sure you convert your coefficient into power.
Yeah.
Okay? Fun, fun.
Let's do B too.
B, we have 8 ln of A plus ln of 2B plus 1 minus 1/3 of ln of C. Step 1,
Give the coefficient.
the coefficient becomes power. So we have ln of A to the 8, ln of 2B plus 1, ln of C to the 1/3, but C to the 1/3 is same as cube root of C. So you can use either one of them.
So you're gonna see points.
No, one of them is fine, any one of them. Either C to the 1/3 power or cube root of C, anything is fine. In the final exam, they will give you root, radical, not as a power. So since we have a plus minus combination, that means we have a fraction. What goes on the top? A to the 8.
Then step
2b plus 1.
2b plus 1 equals
2b plus 1. Cube root of c or c to the 1/3 power. Question? And now the last topic. Oh no, I forgot there was 13. But we did 13 just yesterday, so it's fine, right? So it doesn't matter what is given to you. If you have a single log, you need to convert into exponential. If you have more than one log, you need to combine them into single log first. Let's do E or C. No, what's happening? Man, why it's doing this? So we have log 4 x minus 5 log 4 x plus 7 equals 3. Anytime you have more than one log in one side, we cannot do anything until we combine them into one. So just like the left page, if you have more log and we want to combine into a single log, what do we do with the argument here? Do we multiply or do we divide? So we have x minus 5 times x plus 7 equals 3. And now we have a single log. When you have a single log in one side and number to the other side, we convert them into exponential. So we have 4 to the 3 equals x minus 5 times x plus 7. If I remember correctly, it will give you x squared plus 2x minus 35. And 4 cube is 4 times 4 times 4. 54. 64. It's okay, we are having fun. So you subtract 64 and we get x squared plus 2x minus 99. Stephanie.
So anytime that we have
A single log
we take the base and we make it
to the power.
we get rid of log.
That's why it's called conversion. It's converting log into exponential. So no more log. So which two numbers multiply to 11 combined to 2? Positive 11, negative 9. That gives us x is negative 11, x is positive 9. But for logarithmic function, probably I'll give this in a multiple choice question. No, never mind. If I do that, people substitute and then no. This will not be multiple choice. So once you get it, if you say, oh, these are our answers, you're going to get 0. Because you need to check. Something is wrong with my computer. What's wrong with this? So I have here. Okay. So we check. Can I insert a page?
Is it the one where we get a positive number?
I hate this, huh? Yeah. So when you check, you need to use the initial one, the first one. So we have log x minus 5 plus log x plus 7. If you substitute x with negative 11, we get negative 11 minus 5 That gives us negative 16, but log cannot have any negative number or 0. So we cannot take negative 11 as an answer. We don't even have to bother with the next one to check, because once the first one is negative, the next one doesn't matter. Okay, so I'm going to give one here. One of these. From change of base, definitely one. So let me get a page here. We have log base 5 of 479. When I say use change of base, so first step must be change of base. You need to change your base. And then give me the decimal.
Is this the one where we put log over log,
Mm-hmm.
the natural or the
Mm-hmm.
so it's 479 or
479 over 5. So log of the
the argument?
argument divided by log of the base. And if I'm not wrong, the answer is 3.83.
Yeah.
If you don't show me this, I'm not going to accept your answer for the next one. No, I'm just showing you the circle thing is very important. Next, we have solving ln problem. Ln of 2x minus 3 equals 6. We need to get rid of ln. What do you do? What's the opposite of ln? A. So we apply E on the base. We don't multiply, we apply on the base. So the die, we have 2x minus 3 is e to the 6. Add 3. So e to the 6 plus 3 divide by 2. X is e to the 6 plus 3 divided by 2. One of these are shorter. Stephanie.
So this is for like what is the
It's a log equation, but with natural log.
Okay, so then we have to make E the base for each side.
So when we have only log with, let's say log y is x, we do 10 to the power x is y, right? For natural log, if we have this, we have an invisible e here.
Okay.
So that's why we write e to the x equals y. Let me tell you what will be from chapter 13. One, from converting into standard form and find out center and radius.
Okay.
One, from finding the equation of the tangent line. And one, distance formula.
Wait, for the tangent line, you want us to write like what tangent you want us to
Let's do this question. We have a circle. That circle has a center 0, 0. And the radius has the other end 12, negative 5. So first step, we find the slope of this radius.
write like the slope of the C line, 12, right? That is just one right?
Now you're going to find the equation of the tangent line.
You don't want us to write the
You don't have to write all the details. So first we find the slope of the radius. Our slope is y2 minus y1 over x2 minus x1. Now let's say this is x1, y1, this is x2, y2 for now. So we get negative 5 minus 0 over 12 minus 0. That gives us negative 5 over 12. So slope of the tangent line, it's the other way around. Positive 12 over 5. So the equation of the tangent line is y minus y1 equals slope x minus x1. Y minus negative 5, slope is 12 over 5, x minus 12. So we have y plus 5 is 12 over 5x minus 144 over 5. We distribute, subtract 5, but in order to subtract 5, we need the same denominator. And since we have the same sign, that means we keep the sign, but actually we add the numbers. So we have y equals 12 over 5x. 12 over 5x minus 169 over 5. And you know how to find the center, right? Center and the radius. Let's do it real quick. We do x squared minus 6x, y squared plus 8y. We kick out the constant. So we put something. So negative 3, we add negative 3 squared. We divide by 2, that gives us 4. So we do 4 squared. So x minus 3 squared, y plus 4 squared, we have 11, 9, and 16. So we have, this is the format. First you write standard form, and then our center is 3, negative 4. So opposite of the inside, and our radius is square root of whatever we have on the other side, which is 6. One more, the last one, distance formula. That's it. This is the last question. I don't have space here, so let me get a page. Distance. Do you remember the distance formula?
Yeah. Square root of x2 minus x1 squared
X2 minus x1 square,
plus y2 minus
y2 minus y1 square. So x1, y1, x2, y2. 6 minus negative 4, double negative, okay, not one negative, plus negative 1 minus 7 square. That gives us plus, we get 10 here. 10 square, and from here, negative 8 square. 100 plus 64, 164. So 16 and 4, they both are divisible by 4. So I do 4 and 41. So square root of 4, square root of 41. That gives us 2 square root of 41.
Are you gonna ask this question private?
You should, because in the final exam they have simplified multiple choice. You can buy it from Staple, and after the exam, you can return it.
Do you know which one is best?
Anything you feel comfortable, like either you can buy a scientific one or you can buy a graphing one.
So, for example, if I'm buying, like, what should I do? Same thing.
If you are really buying it and want to keep it, and when you want to use it for the next class, then you should buy either 84 or 89.
It's like just a number.
TI 84 or TI 89. 84 or TI 89. If you want to keep it, but if you just want to use it, then just buy a simple one, scientific one. Bye, Allah Hafiz. No, it doesn't matter. You're not allowed to use phone in the exam. So if you don't bring a calculator, it means you're going to miss all this calculator portion. And it's the same rule for the final exam. In the final exam, someone from the department actually comes and they check everyone. No, they come to see, do you have any Apple Watch? Are you using the calculator or those things?
I
Yeah.
gave you life, it's so right.
It's bad.